Hello students, in previous lecture we have completed the topic from mathematics 2, that is parallel lines. Then we have to discuss about the chapter from mathematics 1. Already we have completed the two topics from mathematics 1, that is maths 1, the chapter number 1, that is sets, and the chapter number 2, real numbers. Then today we are going to discuss on the chapter number 3, that is polynomials. That is, today we are going to start the topic number 3, that is polynomials from maths 1. Then first of all we have to remind the examples of algebraic expressions. All of you studied about that. What is algebraic expressions and examples of algebraic expressions, that you have learnt in previous standard as well as from 5th to 8th standard, as well as you have studied about that algebraic expressions, polynomials, types of polynomials and degree of polynomials, and examples which is related with those polynomials. You have already studied about that in bridge course program. Then today we are going to discuss about those algebraic expressions as well as polynomials, types of polynomials, degree of polynomials, and standard forms of those polynomials. Then we have to remind those all concept which is given in this chapter, that is polynomials. See here, first of all, algebraic expressions. Then what is algebraic expression? Algebraic expressions are nothing but these are the few expressions which is given in the form of numerals as well as using alphabets in it. For example, see here, x square plus 7 is one of the algebraic expression, as well as 9y cube minus 2y square plus 7, also example of algebraic expression, as well as 3a raised to 5 is also one of the algebraic expression, that here 2x minus 5y. These are the few examples of algebraic expression. See here, there is numericals as well as alphabets are used to express those all expressions. Therefore, these are called as algebraic expressions. Then, see here, generally those algebraic expressions which are known as polynomials. Then we will discuss on polynomials. Then see here, poly means many, and polynomials, that is many terms. That means, see here, what are polynomials? Polynomials means it is an algebraic expression in which many terms are there, whether it is one term or two terms or three terms or more than three terms are there. That means polynomial is one of the algebraic expression in which the power of those variables which are positive integers or 0, that means it is a whole number, then that algebraic expressions are called as polynomials. For example, see here, examples of polynomial. Here, x square plus 7, in which there are two terms are there. See here, first term in which coefficient which does not see here, that means there is one coefficient is there, x is variable and here degree is 2, and in another term, that is in second term, that is 7 is coefficient. We can't see the variable here like that, therefore we can express this polynomial in the form of 1x square plus 7x raised to 0. That means there are two terms present in this algebraic expression, and here the variable x, of which degree is 2, because here degree, that power of that x is 2 and here power of x is 0. Therefore the highest degree which is seen here in this algebraic expression, that is the degree of that polynomial. Therefore here degree of variable is 2, as well as here degree of variable x in second term is 0. That means 2 or 0. That means here degree of variables is positive integers or it is 0. That means it should be whole number. That algebraic expressions are called as polynomials. For example, see here 2x minus 5y, in which degree of this term is 1 as well as degree of minus 5y term is also 1. Therefore it is a polynomial. Then one more example, that is root 3x plus 5y. Here in this example, here root 3 is coefficient of the first term, x is a variable and degree is 1. Here also in second term coefficient is 5, y is variable and degree is 1. Therefore here power of those variables is positive integer, therefore it is also polynomial. Example of polynomial. Then see here 1 upon y plus 7. See here, is it polynomial? Then we have to find out whether this given algebraic expression is a polynomial or not. Then first of all, see here y variable is in the denominator. We have to convert it into the form of term, that is in which variable should be in numerator. Therefore that can be written like this. Here 1y raised to minus 1. Using the rules of indices, here y raised to 1 is there. But when y is taken in the numerator, then the rule of indices, that index, sign of that index, it changes. That is opposite. Therefore 1y raised to minus 1 plus 7. Here variable is not there, therefore 7y raised to 0. Here degree of first term is minus 1, or degree of y variable in first term is minus 1 and degree of y in second term is 0. But here degree is not the positive integer, or therefore here 1 upon y plus 7 is not a polynomial. It is not an example of polynomial. Then that type of examples which is given in the practice set 3.1, then we have to identify which one algebraic expression is polynomial and which one algebraic expression is not a polynomial. Then see here, there are few examples which are given here, that is root 3 a cube plus 1 upon 2 b square plus 7. Then is this algebraic expression is a polynomial or not? Then first of all, see here in the first term coefficient in first term is root 3, which is a real number. Here variable is a, and here degree of power or exponent of variable a is 3. In second term, coefficient is plus 1/2. Variable is b, and here degree is 2. In last term, third term, the coefficient is 7. Variable is not seen here, therefore here a raised to 0. Therefore variable is a and degree is 0. Then see here, degree of that a and b variables is positive integer of 0. That means it is a whole number. Therefore it is an example of polynomial. That means we can identify the given algebraic expression is a polynomial or not. Then we have to solve the examples from practice set 3.1. Then see here one more concept. All of you studied about that. Types of polynomials. Then here types of polynomials which is based on, that is, number of terms present in it. Then depending upon number of terms present in the polynomial, there are generally, see here, monomial. Second one type, that is binomials, and last one, that is trinomials. Then see here, monomials. Mono means one. Monomials, that means it is a polynomial in which one term is there. Only one term is there, that is monomial. Then binomials, it is a polynomial in which two terms are there. Then that are called as binomials. And trinomials, in which there are, tri means three terms are there in the polynomial, are called as trinomials. Monomials, for example, see here, minus 5x. It is a monomial in which coefficient is minus 5, variable is x, and degree is 1. Then 3x raised to 5 is a monomial. Then minus 7y square is a monomial, as well as 1/2 x square is also monomial, as well as, see here, 6 is a monomial, because 6 can be written like this, 6x raised to 0. That means there is only one term is there. Or minus 5 is an example of monomial, because here minus 5 is also written in the form of minus 5x raised to 0. Then here only one term is there, and those terms are also called as constant terms. Those terms are called as constant terms. Then what is constant term? These are the terms of polynomial in which the degree of variable is 0. Then those terms are called as constant terms. Then examples of binomials. See here few examples of binomial. For example, 2x plus y are the few examples of binomial 2x plus y. Here two terms are there. Then 5a square plus 7b. That is also example of binomial. As well as x minus 5 is also example of binomial. That are the few examples of monomial, binomial, as well as we can write or give the few examples of trinomials also. That is 2x square plus 5x plus 7 is one of the example of trinomial. As well as we can write minus 5x raised to 3, that is x cube, plus 2x minus 7. Those are the examples of trinomials. Then see here, that is the types of polynomials which is based on number of terms present in it. That is monomial, binomial and trinomials. Then those polynomials can be represented by using, that is, which is denoted by px. For example, px is equals to, see here, x square plus 7 is a binomial or polynomial. Let this polynomial in x term, that is x square plus 7. As well as, see here, 9y cube minus 2y square plus 7. That is the polynomial in y variable. That is 9y cube minus 2y square plus 7. If there is one more polynomial, that is 7x raised to 5 plus 2x square minus 9, then let us consider qx, because there is one of the polynomial which is in x variable is given. If there are second polynomial which is in also given in x variable, then we can denote it by qx. That means it is also polynomial in x variable. That is 7x raised to 5 plus 2x square minus 9. Then see here, we have to discuss on degree of polynomials. Then see here, few examples are there. That is, say px, that is polynomial in x variable is given here, that is x square plus 7. Then first of all, we have to write those polynomials in their standard form, there, or it is written in their index form. Therefore, see here, that polynomial is written like this: 1x square plus 7x raised to 0. That means there are two terms in which x variable is there, and therefore here degree of first term is 2 and degree of, that is power, exponent or degree or power of x variable is 2 as well as here 0. Therefore, the highest degree of variable in the polynomial is the degree of that polynomials. Then here degree of polynomial, the polynomial in which one variable is there, that means the degree of polynomials in one variable. Then here we have to find out the highest degree of that given variable, that is the degree of that polynomial. Therefore here degree of that polynomial in x variable, that is x square plus 7, is 2. Similarly, then see here, 5x square minus 7x raised to 5 plus 2x cube plus 19. that is one of the polynomial, that is qx is a polynomial. Then see here, first of all we have to write it in its standard form or index form. Therefore we have to write those terms in the polynomial in its ascending form or in its descending form of their degrees of variables. Then see here, the highest degree of x variable, that is here x raised to 5. Therefore first of all we have to write, that is qx is a polynomial in x variable, that is minus 7x raised to 5. Then the degree is 3, therefore here 2x cube. Then here plus 5x square plus 19. Then see here 5, 3, 2 and here 19x raised to 0. Therefore here highest degree or highest power of x variable is 5. Therefore here degree of this polynomial is 5. Then see here we have to discuss on the degree of polynomial if there are two different variables are present in it. Therefore we have to discuss on degree of polynomials in which two variables are used there, or two variables, two or more variables, two variables or more than two variables are there. Then see here, for example 5x square y square plus 7x square y plus 9. Then see here that there are two different variables are there, that is x and y. And here in first term the degree of that variables in first term, that is degree of x is 2 as well as degree of y is 2. Therefore we have to write the sum of the degrees of those two variables. Therefore here 2 plus 2, that is 4. In second term the degree of that second term variable in second term is, that is degree of x is 2 and degree of y is 1. Therefore here degree of variables in second term is 3. And here 9 is written like this, 9x raised to 0. Therefore here degree is 0. Therefore there are 4, 3 and zeros are there. Therefore here highest degree of variable is 4. Therefore degree of given polynomial is, that is 4. That means one more example we will discuss here about the degree of polynomial if there are more than one variables are there. Then minus 5 m cube n raised to 4 plus 2 m cube n minus 3 mn plus 7. Then see here in this polynomial, here the degree of first term, that is 3 plus 4, that is 7. Here degree of variables in second term, that is 3 plus 1, that is 4. And here degree of variables, that is 1 plus 1, that is 2. And here 7m raised to 0, that means degree is 0. Therefore degrees of variables given in the terms of that given polynomial is 7, 4, 2 and 0. Here highest degree is 7. Therefore degree of above polynomial is 7. Then here the constant term, if it is given, then degree of constant term that is also 0, or it is always 0, because -7 is a constant term which can be written like this, -7 x raised to 0. Therefore here degree is 0. Or 5 is written like this, 5a raised to 0. Therefore here degree is 0. That means degree of constant term is always 0. Then according to the degree of those polynomials, we can classify those polynomials in different categories. See here, now we can discuss on the types of polynomial depending upon degree of those polynomials. That is types of polynomials based on degree of polynomials. Then see here, for example, these polynomials are classified into different types. First one, that is linear polynomials. Second, that is quadratic polynomials. And third one is cubic polynomials. Then see here, what is linear polynomials? Linear polynomials, these are the polynomials of which degree is 1. For example, 7x plus 5. Then let this polynomial is considered as polynomial in x variable, that is 7x plus 5. That is written here, 7x raised to 1 plus 5x raised to 0. Therefore here degree of this polynomial is 1. And when degree of the given polynomial is 1, then it is a linear polynomials. Then see here, we can write the few examples of linear polynomials. That is 3x minus 2y. See here, in the first term degree is also 1, as well as in second term degree is also 1. Therefore here highest degree of this polynomial is 1. Therefore here degree of this polynomial is 1. Therefore those are the few examples of linear polynomials. As well as the quadratic polynomials. Then if the polynomial of which degree is 2, then that polynomials are called as quadratic polynomials. For example, here qx, that is polynomial in x variable, which is given here, 5x plus 7x square. Then see here, there are two terms in which here degree of that variable in first term is 1, and here degree of second variable in second term is 2. Therefore degree of given polynomial is 2. Therefore it is a quadratic polynomial. As well as here x square plus 5x plus 7. let this polynomial Rx, that is x square plus 5x plus 7. Here degree of this polynomial is also given here 2, because here first term 1x square is there. Degree of first term, that is degree of variable in first term, is 2, while degree of variable in second term is 1, and degree of the last term, that is here 0, because 7 is written in the form of 7x raised to 0. Therefore here degree of those three terms in this given polynomial is 2, 1 and 0. Therefore the highest degree of x variable in this polynomial is 2. Therefore it is a quadratic polynomial. Then cubic polynomials. Cubic means here degree of given polynomial is 3, then it is a cubic polynomial. For example, here if px is given here, then 7x cube minus 5x plus 9, then it doesn't matter how many terms are there, but here the degree of given polynomial, if it is 3, then it is a cubic polynomial. See here there are 3 terms, but as there are 3 terms, therefore it is a trinomial. Depending upon terms present in it, we can classify this polynomial into trinomial. And here in the first term the degree of x variable is 3, in second term degree of variable in second term is 1, and in last term, that is constant term, degree of x variable is 0. Therefore here highest degree is 3 in this given polynomial. Therefore it is a cubic polynomial. Here one more example, that is qy, that is see here 5y cube. It is also cubic polynomial. See here there is only one term, but degree of this polynomial is 3. Therefore it is a cubic polynomial. That means here we can classify polynomials into many categories depending upon the degrees of those polynomials, as well as we can write the standard forms, that is standard forms of those polynomials. Then see here what is the standard form of linear polynomial. See here ax plus b is a standard form of linear polynomial, as well as what is the standard form of quadratic polynomial. Here ax square plus bx plus c, then it is a standard form of quadratic polynomial. That is the standard form of quadratic polynomial. It is a standard form of linear polynomial. And here standard form of cubic polynomial is ax cube plus by square plus cx plus d. That is the standard form of cubic polynomial. But here one precaution is taken here, that is here a should not be 0, and whereas a and b both are real numbers, any real numbers. Here also a, b, c are real numbers, but a should not be 0, as well as here a, b, c, d, it may be any real number, but a should not be 0. That are the standard form of given different types of polynomials. Then the last concept That is, here we can write the standard form of polynomial in which the degree is n terms are there, and we can write the standard form of polynomial in which degree is n. Therefore, we can write this a(n) x raised to n. That means here a(n) means that is a coefficient plus a(n minus 1) raised to x raised to n minus 1. And here like that we can write plus a(n minus 2) x raised to n minus 2, like that here, or a3 x cube plus a2 x square plus a1 x raised to 1 plus here ax raised to 0, or a0 x raised to 0. That is the standard form of polynomial in which n terms are there. It is about the polynomials and their types as well as the degree of polynomials, which are discussed with the help of examples. Then we can write those polynomials in different forms, and we will discuss about that in next lecture. Thank you.